Okay, so yesterday we finished completing the square. There's only 3 textbook questions that I'm going to give you guys some time to do after this, but I am going to just continue with completing the square because we're doing the same thing, and then you'll have the rest of the class to work on homework questions. Okay, plus you'll have your weekend to do it as well. So it says rewrite each function in vertex form by completing the square. So this is what we did and we finished at the end of class yesterday. Okay, so we took each kind of couple steps and we'll kind of go from here. So I'm going to look at the first 2 terms and I am going to pull out the leading coefficient because I want that x squared all by itself. So y is equal to the leading coefficient between 4 and 24. Okay, the leading coefficient is 4, so I'm going to pull a 4 out. That means that I am going to have x squared, 24 divided by 4 is 6, so plus 6x. I'm going to leave a space, and I'm going to close my bracket, and then I'm going to put plus 12 over here. The reason that I leave a space is because yesterday we talked about, okay, x squared plus 6x plus a c value will make my perfect trinomial. Okay, so I need to think, what is going to make x squared plus 6x plus c? What value makes it my perfect trinomial? So I know that if I split 6x, okay, what plus what is going to equal 6x? It's going to be 3 and 3. Okay, so I'm going to go 6 divided by 2 to figure out 3. 3 squared is 9. So I know that I'm going to add a 9 here. Okay, we talked yesterday that, okay, well, if I add a 9 here, then I need to somehow deal with that 9 and put it on the outside. So I'm technically not changing the equation at all because you can't change the equation. But because I pulled out this leading coefficient, I have to think, okay, well, I'm technically not just only adding a 9. 4 times 9 is, I'm actually adding a 36. So if I'm adding a 36 there, I need to make sure I'm also going to subtract a 36 on this outside here. Okay. Now I'm going to take it one step down. So I have y is equal to, okay, 4. Now I'm going to take my x squared plus 6x plus 9, turn that into my perfect trinomial factor, which is going to be x plus 3 all squared. Okay, that's what that gets changed into. Then I have my positive 12 minus 36. That becomes negative 24. So then this is my lovely vertex form now. Okay, I'm going to keep doing all these examples. I know you probably have them, okay, down by now, but some of them aren't always going to be so perfect. Okay, so here I'm going to take out my leading coefficient. My leading coefficient is negative 5. So then I have x squared minus 12x. I'm going to leave a space, close the bracket, and then I have negative 173 out here. I need to think, what is x squared minus 12x to make my perfect trinomial? 12 divided by 2 is 6. Negative 6. 6 squared is going to be 36. So I'm going to add a 36 here. Because I added a 36, there is a coefficient I pulled out. So negative 5 times 36, okay, is going to be negative 180. So if I'm actually having a negative 180, that means that I need to make sure that I'm adding my 180 here on the outside. Okay, now I'm going to take it one step lower. I'm going to rewrite. So I have negative 5, then I'm going to rewrite my perfect trinomial. I have x minus 6 all squared, and then negative 173 plus 180 gives me a positive 7. This is then my final answer here. Sometimes I don't have a c value, but that is okay. I'm going to pull out my leading coefficient. So y is equal to, I'm going to take out a 12. So then I have x squared, and I get minus 2x. I'm still going to leave my space, and then I technically have a plus 0 on the outside, so I don't have to write anything. Okay. x squared minus 2x plus what is going to give me my perfect trinomial. So negative 2 divided by 2 gives me, is my negative 1. Negative 1 squared gives me a positive 1. So I'm going to add this here. Okay, 12 times positive 1. I'm not just adding a 1. I'm technically adding a 12, meaning that I'm going to subtract a 12 out here. So I'm not actually changing my equation. My equation is 12 on the outside. My perfect trinomial gets put into x minus 1 all squared. And then there's just this negative 12 out here. Awesome. Okay. This is going to be my last kind of normal one, and then we're going to split into stuff that maybe won't be as normal. My leading coefficient, okay, please remember that there's this phantom one here when I have negative x squared. So my leading coefficient here is I'm going to take out a negative 1. I'm just going to write negative, and then I have an x squared, so that means that I have a positive 8x, leave a space, close my bracket, and then I have plus 3 over here. Okay, so 8 divided by 2 is 4. 4 squared is 16. So I have a positive 16 that I'm adding here. Because I'm adding it, I need to make sure that I am also going to take it away. But because this is my leading coefficient of negative 1 times 16, I'm technically adding a negative 16. So that means that I want to make sure if I'm adding a negative, I just want to add my 16 out here. So then I'm going to cancel that transaction out. So my final answer is going to be f of x is equal to negative. My perfect trinomial is x plus 4 squared. And then 3 plus 16 is a positive 19. Perfect. Okay, so E, we're going to do the exact same thing, but now if you notice, okay, I'm going to pull out my leading coefficient. So I have f of x. My leading coefficient is 1. So I'm going to have my bracket x squared plus 5x. I'm going to leave a space, close it, and put plus 3. Okay, but when I think of, okay, well, I have to go 5 divided by 2. 5 divided by 2, well, that's 2.5, or as a fraction, that's 5 over 2. Okay, well, then I know that I have to take whatever that is divided by 2. So 5 divided by 2, okay, is 5 over 2. And you technically have to square that then to get your C value. So technically my C value then is a positive 25 over 4. Okay, because 5 squared and 2 squared, I get 25 over 4. I'm going to keep it as, because this is all nice and whole numbers, I'm going to write as my fraction. Because I added the 25 over 4 here, I'm going to make sure I subtract the 25 over 4 over here. Okay, so I'm going to keep in with what I was doing the whole time. So f of x is equal to my perfect trinomial. If it was this question up here, okay, it was just what's negative. If I was doing this question up here, I was thinking, well, what's negative 2 divided by 2? Well, that's negative 1. That's going to make my perfect trinomial. So the same thing I'm going to do over here. F of x is equal to, okay, I'm going to have x, 5 divided by 2. Okay, that's 5 over 2. So x plus 5 over 2 squared. And then I have positive 3, subtract 25 over 4. I need to make sure that you can use your calculator if you don't like dealing with the fractions, but it ultimately comes out to negative 13 over 4. And this is my final answer here. Okay, so you're still doing the same steps over and over again, except for now we're dealing with some fractions. If we look at this one, now we have some decimals in here. Okay, So y is equal to, let's pull out the leading coefficient. The leading coefficient is 3. So I'm going to divide a 3 out. I have x squared, negative 4.8 divided by 3. I get negative 1.6x. I'm going to leave a space, close the bracket, and I'll write minus 2 on the outside here. Okay, so I have to go negative 1.6 divided by 2, and then I'm going to square that. I should get positive 0.64, because negative 1.6 divided by 2, you should get negative 0.8. I'm going to square that, and I get 0.64. Okay, because I added a 0.64 here, okay, and there is a leading coefficient, it's technically 3 times 0.64. Okay, that's a positive, so that means I need to subtract, which it came out to be 1.92. Okay, and then I'm going to rewrite. So y is equal to 3. My perfect trinomial comes out to be x minus negative 1.6 divided by 2, which is 0.8, all squared. And then I have negative 2 minus 1.92, which is negative 3.92. And this is my final answer. Okay. So here, let's do another example. Convert y is equal to x squared plus 3 over 2x plus 1 into vertex form, then use technology to verify that the two forms are equivalent. Okay, so I'm going to write y is equal to, there's no leading coefficient, so I'm going to have x squared plus 3 over 2x, leave a space, close the bracket, add 1. Okay, I'm going to figure out, well, what is my c value that's going to go here? So I have 3 over 2 divided by 2, which I get 3 over 4. And then I'm going to square that, so I get a positive 9 over 16. Okay, because I added 9 over 16 here, and there's no other leading coefficient than 1, I need to make sure I'm subtracting it on this side. Okay, I'm going to rewrite my formula, so I get y is equal to, okay, x plus 3 over 4, all squared, and then 1 minus 9 over 16. It's the same as me saying 16 over 16 minus 9 over 16. I get plus 7 over 16. Okay, so what I'm going to do is you guys are going to do the same thing. You're going to take out your calculators. We are going to go y equals. In our y1, we're going to write out our first equation that we were given, the standard form. So y is equal to x squared plus 3 over 2x, and then plus 1. Okay, if you want to graph it to make sure that you can at least see it, okay, so I can see my point here. Okay, I graphed that one. Okay, in your y2, you're going to write the formula that we just did. Okay, so bracket x plus 3 over 4, close bracket, all squared, and then plus 7 over 16. When I click graph, okay, to confirm that the two are equivalent, I should have one graph. I should graph it, and I should only be able to see the one graph here. Okay, which you see that I don't have a second graph on here, meaning that I only do have one graph. Okay, if I can move this all around, I can change my window settings, okay, and it shouldn't make a difference. Perfect. Okay, so while my computer here, or my piece is going to let me go back, you are all going to try the your turn, and then I'm just going to write the answer down here. So you can pause it for a second if you want, but you are going to do the your turn to get this y is equal to negative 5x squared minus 30x minus 41 into vertex form. Then I want you to determine if it's a minimum or maximum just by looking at your vertex form. Okay, pause it, and then I want to see everyone doing it. Okay, so your answer should have been y is equal to negative 5 x plus 3 all squared plus 4. Okay, once you change that up, okay, I know that it's going to be a maximum point because it's a negative 5, so that means that I have a negative a value. So I know that it's opening downward, so I'm going to have a maximum point. And looking at my vertex, okay, I know that if I see this 3 here, because it's positive, I'm going to flip it. It means that I have a negative 3 as an x value, and my 4 is going to stay the same. So I have negative 3, 4. Perfect. Okay, so I'm going to do one kind of word problem with you here, and then you're going to do one on your own, and then you guys are going to have some time to do some textbook questions. Make sure that you're going to be kind of masters of perfecting the square, okay, completing the square. Okay, so it says the student council at a high school is planning a fundraising event with a professional photographer taking portraits of individuals or groups. The student council gets to charge and keep a session fee for each individual or group photo session. Last year, they charged $10 a session, and 400 sessions were booked. In considering what price they should charge this year, student council members estimate that for every dollar increase in the price, they expect to have 20 fewer sessions booked. So let's write a function to represent the situation. Okay, so we first have to define our variables. Let's let n, okay, be the number of increases that we have. Okay. So we're going to let n be the number of increases. So if I have, this is kind of like a revenue question. So my revenue is going to be equal to the cost of a session. Okay, based on the number of sessions. So before we kind of take a look at all of this, we kind of need to think, okay, well, if I have $10 is what they charged last year. So let me write this down. If I have $10 for a session fee, okay, that was last year. And then I also had 400 sessions. They're telling me that I'm going to, for every dollar increase, okay, that means that I'm going to have 20 fewer sessions. Okay, so it's me talking about the dollar increases. So that's, if that's per one, and then I'm going to have 20 fewer people down here. So for a cost of a session, I'm going to go back here. My revenue is going to be, for a cost of a session, we're going to say it's going to be $10, okay, because that's for their session, but they're going to add, okay, n, okay, number of increases. For every number of increase, we're going to times that by, it's going to be the 400 sessions minus 20 people for every number of increase. Okay, so the function is going to be cost of the session times the number of sessions. So it's going to be $10 plus the 1. Okay, that's going to be your number of increases. And then we're also going to have 400 minus 20. I'm going to expand this out, okay, because I'm going to multiply this all out. I'm going to get my R is equal to, okay, to write it out nicely, because I'll get 4,000 minus 200n plus 400n minus 20n. So minus 20n squared plus 200n plus 4,000. Okay, so I have this standard form parabola here. Okay, my next question is asking what is the maximum revenue they can expect based on these estimates. There's no need to graph anymore. Okay, I don't need to graph this anymore because I know how to take this and get my vertex form from it. Okay, so I'm going to take my equation. So R is equal to, I'm going to take this equation here and I'm going to turn that into vertex form. R is equal to my leading coefficient. My leading coefficient is negative 20. Okay, I'm going to pull that out here. I get n squared and then minus 10n. I'm going to leave a space and then plus 4,000. Okay, so I have negative 10 divided by 2 is negative 5. Negative 5 squared is a positive 25. Okay, so positive 25 here, negative 20 times a positive 25. That means that I'm at a negative 500. So that means I need to add 500 here. Okay, so my revenue comes out to be negative 20 bracket. I'm going to get n minus 5 squared plus 4,500. So looking at this, I can tell my vertex is going to be a positive 5 and a positive 4,500. So that's telling me that my maximum revenue is going to be, okay, revenue is the dollar amount, so it's going to be $4,500, okay, and then it's telling me here, sorry, I was just reading what the actual question is saying, so it's telling me here that it's 5, but that counted for the number of increases. So that means that it's 5 increases, and each increase was $1. So that's 5 plus the original 10. So my maximum revenue is going to be at $4,500 when it's $15 a session. Okay, so revenue questions are very common for us to test on and to do like this. And the hardest part is just to kind of think, okay, well, what is my revenue when it kind of comes down to it? Okay, and it's going to be your cost of the session, okay, times your number of sessions, which that kind of makes sense. Okay, however much money you make times how much the cost of one session times however many sessions you have. Hardest part is just breaking down what your pieces are going to be. Okay, so here's the your turn in a formula. Okay, you can pause it here, give them 5 minutes to try on their own, and then I will write out their pieces here, the answers. Okay, so I'm going to let n be the number of increases. So I said, okay, well, it was going to be $8. And then for approximately 100 items. Okay, so for every $2 of increase, And then they were going to expect to sell -5 down here. Okay, -5N. Okay, so again, when I'm talking about revenue, it's going to be the amount, the items, okay, times your amount. So my revenue is going to be 8 plus 2N times 100 minus 5N. So my revenue is going to be -10N squared plus 160N plus 800. Okay, for determining the maximum revenue, you're going to take your formula, turn it into a vertex form. So I get -10 and minus 8 squared plus 1,440. So the max revenue comes out to be the $1,440 with a selling price of $24. Okay, so if that's something that you struggled with or you didn't get, when I come back on Monday, we're going to go over lots of things again. I would like to make sure that you go over your homework just of basic completing the square. So that's textbook page 192, numbers 1 to 3. And your homework for today is going to be textbook pages number 193 to 195, numbers 4, 6, 7, 8, 12C, 14, 18, and 19. Perfect. Okay, if you want to look back at all of this stuff, it's all on OneNote already. If you want to kind of take a look back at it, I am also available for messages on Teams if you need some help. Okay, good luck, and I'm sure you'll do great. See you on Monday.